welcome our first speaker, Mr. Mark McConway. Mr. Mark is the Managing Director at Scotland-based Web System International, which partners with India. He holds a first-class honor degree in business and legal studies and has led various industries, notably in construction, universal design, and manufacturing. Since 2013, Mark has driven innovation in working at height safety solution at Web System International, focusing on underdeck access for bridges, oil and gas, steel plants, and more. His passion in reducing worker time at heights, fostering a global network to enhance safety and efficiency. Mr. Mark will present a talk on reducing the carbon footprints of access equipment. So I welcome Mr. Mark.
So this morning's discussion, over 10 minutes, will be on the potential for carbon footprint savings using WebDeck, suspended access platforms versus standard scaffolding. Now, given that it is only 10 minutes, this will be a very brief overview, and it's not designed to be a rigorous statistical analysis. So a very small amount about Web Systems International. We provide unique access solutions for underdeck works, both offshore and onshore, excuse me, and protecting against dropped objects. As you can see from the photographs, our capabilities include offshore oil and gas, industrial plants, particularly steel plants, bridges, jetties, and high-rise construction. And these are just a few photographs from around the world indicating where WebDeck in particular has been used. So, to start things off, I wanted to take a very quick look at the environmental impact of standard scaffolding and the main issues. First of these is material usage. So the standard scaffolding consumes large quantities of steel, aluminium, and wood. And that's particularly so in the extraction, production, and transportation of these materials, and these can result in significant carbon emissions. Transport and assembly of scaffolding components to and from the construction site involves the use of heavy vehicles. Now, I should also mention that in some of the industries that we're involved with, for example, oil and gas, transportation also involves large amounts of scaffolding being sailed out on barges to oil rigs and other platforms. In terms of waste generation from traditional scaffolding, this is not the biggest issue, as a lot of steel and aluminium scaffolding can actually be recycled. I thought I would introduce this slide into the proceedings. I found it very interesting, and it's taken from a report in 2015 that was actually looking at the comparative carbon footprint versus steel scaffolding. Now, I won't bore you with the details, but what this was indicating, and we'll be able to see from the table, is that in terms of a much reduced carbon footprint, the best choice, believe it or not, would have been bamboo. Now, we are not involved with bamboo, and most countries in the West are not involved using bamboo scaffolding, a scaffold of choice in the Far East. But it does seem to be the case that because it's not uniform in its structure, because it's basically a living organism, because it's not uniform, it can't be replicated scientifically in the same way that steel and aluminium can. So on the right of that table, I just wanted to show you what this report was indicating goes into the making of steel scaffolding. So you can see everything from sintering and coke making at the steel plant. You can see that the energy input comes from coal, gas, electricity, and fossil fuel. And the output as a result of that manufacture is all greenhouse gases. So in the real world of 2024 and in the markets that we work in, the focus is to look at how one could conceivably reduce the use or the overall volume of traditional steel scaffolding. So in order to understand where WebDeck fits in, I need to explain what is a WebDeck. WebDeck is our proprietary name for a temporary work platform. It's hung below structures like bridges, jetties, and offshore assets to provide safe access for maintenance activities. And you can see that with the picture of the helideck on the right-hand side. You can see that there are modular decks underneath this helideck. So these are modular in nature with lengths of 1, 2, and 3 meters with a uniform width of 600 mil. It can be fitted onto independently suspended trusses or side anchor fixed catenary wires. And then it's picked up at intervals by support chains and top fixed using wire rope slings or beam clamps. So you can see in this couple of photographs very clearly that the web deck can create open areas with minimal obstructions. And if that was to be replicated with scaffolding, you would need an awful lot more scaffolding than you would web deck. And then on the right-hand side, you can just make out the steel rope or catenary wire that runs below the decks, which are then clipped onto them and then picked up at intervals using pickup chains. Why we think that web deck would be a useful asset to reduce carbon footprints, you can see it very clearly here that the web deck itself and the components surrounding it are minimal. And on the photograph on the right-hand side of the screen, it's actually quite good because you can also see, in addition to the web deck going up in this pipe rack, you can also see that a significant amount of scaffolding is very often used just to access the point at which work is taking place. So we believe that we have a disruptive solution that is reducing the need for large quantities of scaffolding. We're not in competition against scaffolding. Everything has its place. But in terms of practicalities and reducing large volumes, this is where we think web deck is a useful innovation. You can see here the issues that I've just described. On the left-hand side, you can see that there's been a significant amount of scaffolding required just to reach this inclined conveyor at the top. And on the right of the picture, you can see where we've used our web deck system in a stepped formation that allows access all the way up the incline without the need for obstructing the road below. I think out of all the photographs that I've got that make the comparison between web deck and scaffolding, I think this is the most elegant one, because if you think about this for a second, you can see just running underneath this horizontal conveyor, you have one wafer thin line of decks. Now, I think what you'll notice here is that there's absolutely no obstruction here, not on the road, not anywhere. So if you just imagine for a second how much scaffolding would be required to meet that height, that's where the carbon footprint is greatest, because when ground up scaffolding is required, its quantum will always be determined by the height that it has to reach and the width that it has to span. Now, on the other hand, web deck, as you can see quite clearly here, will be deployed as a single layer, or we can provide it in multiple levels. But whatever the height is, you will only ever have that one single wafer thin line of decks. I mentioned before we were looking at the environmental impacts of traditional scaffolding. Just a few of the benefits of using web deck as an alternative to that. So first of all, material efficiency. The web deck suspended platforms, they use far fewer materials compared to scaffolding. So going back to the production of scaffolding, when we're using web deck, we are using a far smaller quantity of material. So the resources required to manufacture that like for like is much, much lower. And this feeds through to transport and assembly, as we were talking about before, that the lightweight nature of web deck platforms mean fewer trips required for transportation. And going back to what I was saying about the offshore industry, that can be particularly the case with shipping barge loads of scaffolding to and from the oil rigs or floating platforms. And then lower waste production. I would say that similar to scaffolding, the components of WebDeck are very recyclable, but in addition to that, they're particularly durable. So they have a long lifespan, leading to less frequent replaces and lower waste generation. So taken together, I would suggest that WebDeck, and in fairness, similar solutions to WebDeck, should be the way of thinking in terms of reducing the carbon footprint in the industries that I've described, ranging from construction, marine, offshore, and steel plants, etc. So that concludes the formal part of my short overview presentation on the carbon footprint. And I know that there'll be some general questions about WebDeck later on. So thank you very much for listening.
Thank you so much, sir. That was definitely a very insightful speech on how to reduce carbon footprints.